Okay, we're going to take a look at rates of change in tangent lines. I'm going to take a look at an example right here of trying to approximate the slope at x equals 1 for the function f of x equals x squared. So keep in mind that the slope of a line is the change in y over the change in x. You've learned this in the past as y2 minus y1 over x2 minus x1. So here's y equals x squared. We're looking at the point when x equals 1, so the point 1, 1. And if we want to approximate that slope, we can use a secant line, which is a line that connects 2 points on the curve. So we could use the point 1, 1 and the point 2, 4. And you can see it gives us this blue line right here. We can find the slope of that line as 3. So we've approximated that the slope at x equals 1 is 3, although you can see from looking at the graph at the left that that's going to be a little bit too steep. So we can get a better approximation. Let's move the point closer. Let's go with x is 1.1, which would correspond to y is 1.21. And you can see that this is now looking much more accurate for the slope at 1, 1. We can zoom in a little bit here. You can see that close to 1, 1, our blue line is very, very close to the red curve. And we get a slope of 2.1. All right, now we're going to make this point get closer and closer to 1, 1. So if we let x equal 1.00001, if we plug that into y equals x squared, we get a y value of 1.00002, 00001. And we can find the slope of the line connecting these 2 points, 2.00001. So we can see that the closer we get, our slope is approaching a value of 2. Now, we haven't proved this yet. We can confirm it by making that point as close as we possibly can to 1, 1. So here again is the graph of x squared, and we're going to take the point 1, 1, and we're going to move over some distance h, and h is a very, very, very small amount. So the slope is f of 1 plus h minus f of 1 over that change in distance h. And we can make this exact by using a limit. So limit as h goes to 0, we plug 1 plus h into x squared, we plug 1 into x squared, and we simplify this algebraically, cancel the h's. Now we can evaluate the limit, and we've proven now that at the point 1, 1, the curve has a slope of 2. So if you ever want to find the slope of a curve at a point, it's the limit as h goes to 0 of f of a plus h minus f of a over h. We call that, that f of a plus h minus f of a over h the difference quotient. So if we're told to find the slope using definition or using the difference quotient, this is the method we're going to use. All right, so if we find the slope of a curve at a point, that gives us the slope of the tangent line to the curve at that point. So if we find the slope of the point, we can also find the tangent line. So remember that the slope of a line, y minus y1 equals m times x minus x1. We've already found that at the point 1, 1, the slope is 2, so plug all that information in, and we can find that this curve has a tangent line of y equals 2x minus 1 at the point 1, 1. If we want the normal line, which is another way of saying the perpendicular line, all we do is take the opposite side reciprocal, or the negative reciprocal. So if our slope at that point was 2, to find the normal line, the slope will be negative 1/2. So on our calculator, we can see what this all looks like. We can graph x squared, we can graph the tangent line, and we can graph the normal line. And you can see how that all comes together. Okay, let's look at another one. We've got f of x equals 1 over x. We want to find the slope at x equals a. So we use our limit of the difference quotient. Our function in this case is 1 over x. And we have this, these fractions in the numerator, so we want to try to clear that. And we can do that by multiplying by the common denominator, a times a plus h. And simplify, cancel the a's. Now we can cancel the h's. We're left with a negative 1 on top, a times a plus h on bottom. Now plug in h equals 0, and we get negative 1 over a squared. So we want to find out now where the slope is equal to negative 1/4. So set negative 1/4 equal to negative 1 over a squared. And we find that there's two possibilities, a equals 2 and a equals negative 2. And now let's find the tangent line equations when x equals 2 and negative 2. So we already know that the slope is negative 1/4 from the previous step, and we can find the y value by plugging 2 into f of x. We get 1/2. And we can find the equation of our line. Same steps with negative 2. Y is negative 1/2, slope is negative 1/4, and we have the equation of the tangent line. And if we want to go ahead and graph this, here's 1 over x. Here are the two tangent lines, and you can see those both occur at 2 and negative 2. And you can see how those relate to the curve. So some review of today and the lesson we had a few days ago on finding velocity. Our average slope, change in y over change in x, slope at a point is the limit of the difference quotient. And just be really careful whether you're looking for average slope or slope at a point. That difference in wording makes a huge difference. And average velocity, change in distance over change in time, and the instantaneous velocity is the limit of the difference quotient. So again, make sure you're paying really close attention to the wording there, but notice the relationship here that slope and velocity are essentially the same thing. So slope, velocity, and we can see that if we're given position, the velocity is the slope of the position curve.